There, and it is 1 o'clock, and I see a recording button go on. Hello, everybody. My name is David Hensher. Welcome to this breakout session on closing the loop for plastics. I am honored to be the moderator for today's session. I am the communications manager at Recipo, Nordic Producer Responsibility. We have operations in Sweden, Norway, and Denmark, and we focus on taking producer responsibility for electronics and batteries. So one of the reasons that I'm here is I've got my colleague, Michael, who is at Recipo Material, and he's going to be telling us a little bit quickly about how Recipo Group managed to capitalize on the restrictions that were imposed on exporting plastics to Asia, and how we have managed to close the loop on the plastics from our waste streams in Norway, Sweden, and Denmark. I hope everyone can hear me. Michael, please go ahead. Tell us a little bit more about Recipo Material.
I sure will. Thanks, David. I'm just going to share my screen with you all. Look, I'm very excited to hear from you all on ways we're closing the loop for plastics. I will dive straight into it. Recipo Material was launched in early 2020 as a new opportunity for the treatment of plastics. And we endeavour to play our part in redefining the recycling business within Europe. Our vision echoes that of Recipo. We want to create a sustainable society where electronics don't become waste, but are instead circulated to produce new products. Recipo Material is a complete end-of-waste production facility. So we take raw material and produce 100% recycled plastic pellets. We have a fairly standard operating line. We shred, we wash, we sort, and we also extrude. The extrusion is somewhat lacking within Europe because historically we were sending our plastics to China. So we're one of the few that are actually able to extrude plastics here in Europe. We deal with two types of waste streams, that is small domestic appliances or SDA and flat panel displays, FPD. We produce ABS, PS, PCABS, and PMMA pellets from the two streams. We also make ABS FR flakes, and I'll touch on that very shortly. It hasn't been short of challenges getting this facility up and running, but we've managed to succeed, and we're really excited at what the future holds. One of the challenges we faced in our first year of operations is the EU directive for REACH and RoHS compliance. We have had to incorporate this methodology into our entire management system. We are creating and have created rigorous testing procedures. We have to report our findings, and we also need to maintain a high quality of product within the acceptable limits of RoHS and REACH. We do face challenges regarding compliance because of the raw material that we receive, specifically SDA material. It's a highly contaminated material, and by that I mean there are many different types of materials found in SDA, anything from up to 30 types of polymers chemicals. The EU directive for ROSE specifies roughly 10 substances that are prohibited from being exported. And you can see a list on the screen there of the types of prohibited substances. We're mainly concerned at Recipo Material with the polybrominated fire retardant materials. And that tends to find a way what we call heavy flakes. So we are still undergoing extensive and development on Europe, the ABSR, so that only the legal substance remain in the fraction, but the prohibited ones we get rid of, so to speak. We were also challenged by the quality of raw material that we were receiving from our recyclers. There were plenty of foreign objects found quite regularly in our raw material. So we feel that it's very important to maintain a close working relationship with recyclers to eliminate non-plastic materials, and we really want to work cooperatively to increase our overall recycling rate. The third challenge that we faced and continue to face is the ban on mixed polymers into Asia. We can no longer downstream these mixed materials to other recyclers out of the OECD. And we're finding a bit of a lack of viable alternatives for end-of-waste solutions, which is one of the key factors in why Recipo decided to open its own recycling plant. The buck really does stop with us now, so we are looking for cooperations in order to find long-lasting solutions. And just quickly, you can see on that graph on your screen the sharp decline in plastic waste traded with China in the dark blue. It has opened up other markets in other countries. However, Recipo's stance is to really look at finding viable solutions on our home turf. That's basically my short presentation. I didn't have very long, but I will pass you back to David. Thank you.
Thank you, Michael. Thank you for keeping somewhat within the time limit as well. It's very much appreciated. It is a very exciting journey that the Recipo has taken and you know, continuously working on, and being able to close that loop for our producers, potentially then also being able to sell back the material to that producer is just really, really exciting. But thank you for that, Michael. I just want to mention to everyone watching that there is a little chat function. So if you have questions that you would like me to pose on your behalf later during the discussion session, please put those into the chat there, and I'll make a little note and then I'll try and collect them. So if we get double questions, I won't be asking the same one over again. But thank you again for that, Michael. Now I've got the privilege to be introducing Dr. Anupam Khajuria, who is a researcher at the UN Center for Regional Development. And she'll be outlining the challenges in Asia for a circular economy and plastic waste management. So please, Dr. Anupam Khajuria, go ahead.
Thank you, David. Thank you very much. So let me share my slide. I think it's visible.
Yes, very visible, very visible.
Thank you very much. And thank you very much for giving me this opportunity. So today I'm going to discuss about the plastic recycling and utilization of circular economy in Asian perspective. Actually, in Asia, we are producing millions of tons of discarded plastic ends up in the ocean. And there are a lot of waste, which we have to think about how we can reduce it. So in China is the topmost, which producing this amount of waste. You can see in the 5 more countries, first China and the lower part is in Japan. So in DPSIR framework, I will show about the how we can focus on the plastic. Why we focus on plastic? Because we generating a lot of waste as a driving force, which put the pressure on our consumption and sustainable production pattern, and it impact on the environment in land and water. And we have to follow some responses which we are have to be taken care of. And why we are thinking in Asia Pacific region, as you see in this figure, this clearly shows that the more waste is than the fishes in expected in 2050. So that part is most 10 rivers is in Asia, which are generating a lot of waste. The one is in India, and which reflect to Bangladesh, as well as China, as well as Indonesia. So we have to think about, we can control this part, otherwise it's very difficult to manage in near future. So, and also as well as it's significant loss in our economy, because if you say there are many titles in many reports, you can say our plastic waste was in billions of trillions of loss in the in the marine ecosystem. So like Michael already mentioned about the ban in of the like reducing the material recycling facility to the Asian countries. So that's what I'm going to show this. The China is already banned the plastic import from 2018. And after China, as Michael showed in the figure, the most countries is like impacting the rise in the plastic trash exports from Vietnam, Indonesia, Philippines. And in that flow, Thailand is also planning to control this banning maybe next year or this year, but it's because of the COVID, it may delay some time. And it's following the same situation in Vietnam. So basically they are not putting that material as a material recycling sector. So they are using as a material for the banning for the recycling in Asian countries. So that is very important. Before the ban, they should consider, we are thinking about the circular economy, which we can reduce the waste. So maybe we can utilize that material more as to consider this is valuable. So this circular economy, we made focus with the principle of 3R, with the reduce, reuse, and recycle. So I'm not going to much detail because I know in this forum platform, everyone knows the basic concept of the circular economy. So in that part, in control the marine pollution in Japan G20 meeting, we focused on the marine initiative, which based on the 4 concepts, that is management of waste and recovery of marine litter, innovation with the empowerment. So with this aim, we are planning to control and reduce the marine plastic litter to 0 by 2050 in Japan. And the same thing, because they are voluntary action they are taking, and it's not possible without gather the information or updating the information or with the collaboration with the neighbor countries. So same thing in Japan, they are thinking about the transition by the redesigning and reusable for the economic options. And the third one is the recycling the pay. And 3R, they don't think about 3R as a circular economy, we are thinking. They talk a bit about the 3R plus renewable energy, so that we can use the circular economy in the recycled plastic and bioplastics with the support of the government and development of the resource circulation system domestically. Actually, we are organizing, my organization, we are doing the forums, which is we invite in the high-level governmental delegates. And this forum is like, last December, we have the 10th forum, where we discussed about the plastics, and I will show in the next slides the report, which we launched during this forum. But in this report, you see in the forum of the 9th forum, the Bangkok, we prepared the declaration which helps to prevent the plastic waste pollution through 3R and circular economy. So in our UNCRD system, we have also the Hanoi Declaration goals, and these goals are also reflect the proper implementation in Asia and the Pacific region. So we gather the information from Asian and Pacific region, and we try to compile and monitor their situation, what is going on, and what is a possibility they should overcome that situation. So in DPSIR, in the marine litter, I think we should think about the not only the land-based activities, also we think that our coastal tourism, because it's really affected by the plastic waste. And it's all the waste is going to the litter enrich and also loss of the economy. So there are three main things we should consider is identify the source and ultimate end of the plastics and promote greener awareness, because awareness is very important in our region, because without awareness, its collaboration or partnerships is really very difficult. So this I'm create the two different parts, which one first is thinking about the linking with the circular economy. Like EPR is important with when we think about to buy the product in the plastic or even in electronics. And the second, we think about the policy regulations, economy regulations, because the taxpayers have to think about that. And technology, like in the beginning of the presentation, is AI is important now, but I'm thinking about how are the data, because we have limited information of the data. And the volunteer participation, which can collaborate with international organizations, governments, as well as the NGOs. So this is the medium and short-term and long-term solutions, which we think, because when we product plastic production, so that time we can think about the long-term, because we can eco-design that product, so we can sustainably use that product. And the medium in the term is that we can increase the plastic recovery, so which appropriate technology we can use and energy recovery we can create that part. But the short term is to prevent the plastic litter, and that really needs the awareness. So in Bangkok Declaration, we have focused on the three parts. The first one is the development of 3R policies. And the second is multilateral cooperation. And the third one is awareness of the circular economy, because in Asia, we are talking about circular economy, but the basic concept should be very clear. So in this here, I'm introducing about the Society 5.0 for SDG, which can create the creative society based on the science and technology basic plans. And it also delivered the United Nations Sustainable Development Goals. This is the book I'm talking about the beginning. This is a book we prepared on the base of the plastic waste management issues and challenges on circular economy opportunities in Asia and Pacific region. So this is the source book. We understand the situation of the plastic waste in Asia and Pacific region. And also underlying, there are many regional declarations and agreements in addition to SDGs. So this is available in our website, so please freely see it. And now the COVID, because of the COVID, we are doing these virtual things. So in the COVID situation, we see how the plastic in the one bucket, we put everything like Panatin buy with plastic, PPE plastic, food package with plastic, and the behavior they are not aware much. And pharmaceutical, they put everything in combined because of the lackage of the community behavior change and technological informations. So they should think about that part in the beginning of the topics. So I have prepared some strategies. The first is prioritize the sustainable packaging that can reduce also the use of the package and also the product of the plastics. And the second is the economy sector in the plastics, because it create, if we think about circular economy, create jobs, a lot of jobs in the SMEs by the industrial symbiosis factors or by ecotowns projects. So that is a really good thing. And the third is consumers' green behavior, so they can not buy more plastic from the market. And the last one is the AIE, or the frontier technologies, which is really important to understand and to use in the plastic management sector. So in the last, our next forum is in this year. So we are planning the physical forum, but I'm not sure it's possible, or maybe it's hybrid. So I'm really happy to invite everyone. So please join this forum. So you can contact me and send me email, so we can provide the registrations. So thank you very much. Thank you.
Thank you very much. My goodness, that was so much information. Thank you for keeping it down to the time. It makes me feel awful that the time restraints exist, but it is what it is. So many questions, such interesting insights into what it is that you're actually doing. And I've got personally a few questions on how, once you actually achieve this sort of blueprint, how it is that you're actually going to be able to get it through, you know, into a way where it actually, you have this great idea of how to solve the problem, and then you present that, and then there's that next step. Companies, governments, everybody needs to grab a hold of that. But very exciting. We'll keep that and something that we can discuss a little later on. Now I've got the pleasure to introduce Kristin Geidenmark Olofsson. She's Director, Regulatory Affairs and Strategic Innovation at Trio World, and she's going to tell us all about standardization landscape for circular plastic industry. Take it away, please.
Thank you very much, David, for introducing me, and thank you for the invitation to attend to this conference. And I will do as everyone else, share my screen. Actually, I'm employed at the company called, now it's a new name, Trio World instead of Trio Plast. But here I'm representing as my role as convener for the International Standardization Group for Plastics Recycling and the European Standardization Group for Plastics Recycling and the convener for the Standardization Request Ad Hoc Group between CPA, Circular Plastic Alliance, and Senelec. But I will come back on that topic. So, not only in a global perspective, but also in the different continents, plastic strategies is developed. As it looks right now, Europe is leading very much of the development when it comes to strategies on circular plastics. And in the European plastic strategy, it's identified that development of quality standards for sorted plastic waste and recycled plastics is crucial for the circularity to get running. We have experienced that if you don't have standards, you get a very messy and unclear definition and agreement on what is really circular at the end of the day. As a result of the European plastic strategy, the Commission in Europe decided a couple of years ago to create the Circular Plastic Alliance as a voluntary initiative to invite industry and public and private stakeholders to participate in the development of a plan to achieve an uptake of 10 million tons of recycled plastics until 2025 in Europe. And just to understand how the Circular Plastic Alliance is structured, this is the map of Circular Plastic Alliance. It's created of 5 different sectors: packaging, agriculture, automotive, EEE, and building and construction. And then we have a 6th working group, monitoring, that have created the reporting system for the value chain in the plastic industry to report the volume so we can measure if we achieve the 10 million tons or not. For the 5 sectors, all of them have been working on 4 thematic groups: R&D and investments, design for recycling, collection and sorting, and recycled content, in order to enable a plan how to achieve the 10 million tons. In the middle, we have the steering committee. And at an early stage, as a deliverable for the signatories, more than 200, it it was identified that standardization was a key tool to achieve this. So in order to do this, there have been created a standardization request ad hoc group. And to understand what the standardization request is, normally a standardization request is a tool that is used by the Commission to enforce a regulation and to create harmonized standard to be implemented into current regulations or directives. For this standardization request that will come from the CPA input, it will not be related to any regulations, and it will not, initially at least, be used as harmonized standard. And the reason why the Commission have decided to use this tool is that the expectation of the amount of standardization proposals identified in this work is huge, and this is the way to organize it in a timely manner. The Commission have been very clear in the scope of the standardization request, what needs to be covered to enable the circularity of plastics. So we have been working on 4 parts of the scope: design for recycling, quality of plastic waste, quality of plastic recyclates, and integration of recycled plastic in products. And to understand the amount of standards that have been proposed within the 5 sectors in Circular Plastic Alliance, and with help from Joint Research Center, that is the research part of the Commission, there have been identified the biggest volumes of products and materials in the different sectors. So all the sectors have created dedicated product teams that have developed the proposals of the standards within the scope for each and every one of these products. And I won't go through them in detail because then it will be more than 10 minutes. And as you see, the packaging group is, as always, the biggest one, not only in volumes, but also in groups. And a little bit about the standardization organization. So we have the European setup, which is CEN or CENELEC, that have the silo structure. So we have one technical committee working with plastics, one with packaging, one with EEE, one with vehicles. And then on the ISO level, we have similar groups, but not necessarily connected to the European groups. And then we have the overall TCs or creations in the standardization that is not connected to any material, but is concerning circularity anyway. So we have circular economy and SABE in Europe, we have circular economy in international group, but also chain of custody, which is not mirrored in Europe. Historically, these have been working separately, but now in the future, we have to communicate between the different TCs, between the European groups and the international groups. And this is a new structure that is under creation with the work that we have to do within CPA. I had the opportunity, because I'm the convener both for the international and the European groups for plastics recycling. So I have created a mutual group, which is not within the structure and the rules of standardization, actually, but we have mutual meetings, we exchange what projects we are working on and who is doing what. So this is very important for us to create a new way of communicate over the borders. The work that we are doing in Europe is extremely of interest from an international point of view. We have more and more members and countries participating in the international group, but we also have interest and requests from governments in other countries to attend or get information of the standardization work that we are doing in Europe. And also requests from other standardization organizations, for example, ASTM, to participate in the CEN work, which is not according to the rules either. But we try to create an environment where we can have this communication in a good way. So, what is the situation right now? Right now we have collected all the inputs from all the working groups within CPA. So we have more than 230 proposals. Many of these proposals are pointing at the existing standards that needs to be revised according to the sectorial demands. And now we need to align all the sectorial demands into one single standard in some cases. In order, we foresaw this a little bit, so we have created a strategy within CEN TC249 Plastics Workgroup 11 Recycling. How will we want to achieve the deliverable that is expected from the Commission? So we created a strategy based on umbrella standards. So we have an overview standard that can say that within quality of plastic waste, we recommend that each and every sector, if they need to develop a standard, do like this and that. When we did this strategy, we also realized that historical and the old standards are all based on mechanical recycling. And we have to consider the new technologies, the new recycling technologies when we are developing new standards today, because we have considerations that needs to be taken into account with the new technologies, both physical recycling and chemical recycling especially, where there are demands on design for recycling that is not included in mechanical design for recycling guidelines, but needs to be considered for the future. And when we are talking about these technical committees and working group, they are consisting of representatives, experts from industry, business associations, academia, and non-governmental organization, which is very good because we get the very clear environmental input from them. And the situation right now is that the list developed from CPA have been revised or are under revision in the relevant TCs in Sensenelec. We are finalizing that work now, and in June we are delivering the final list to DG Grow, who is hosting CPA. And then the DGs within the Commission will draft the standardization request that will be delivered from the Commission to Sensenelec in December 2021. And if you do a quick calculation, after that the clock will start. Then we need to develop all the standards within the standardization request within 3 years. And that will start then in January, something like that. 2022, 2023, 2024, and the deliverable of the 10 million tons is 2025. But I hope to get a question during the question and answers session later on that will explain how this will be achieved with the help of standardization. That was all from me, and thank you very much.
Thank you so much, Kristin. Wow. It's very, very, very interesting. You will indeed be getting a question a little later, so you'll be able to fill everyone in on that. Moving on, we're going to talk to Cecilia Askham, who's a senior research scientist at NORSUS. She's going to talk to us about her research on the Circular Plastic Project, realizing circular innovation in Norway. Cecilia, please tell us.
Thanks. I'll just share my screen so that you don't have to look at my son's posters of his favourite football team. Let me see. Are you hearing me?
We hear you loud and clear.
Right. Let me see. And then we get to presentation view.
You're not there yet.
How about now?
Nope. We're still seeing how you see
right. Sorry about that. We did have a technical rehearsal the other day. Right, how is it now?
It seems to take a little while for the internet to catch up with your clicks on your computer. That might be the case.
It's telling me it's sharing, so
it is. And what it's sharing is how you see it on your desktop, and it looks like your mouse has gotten stuck down on that presenter view button. So you probably clicked it, and for some reason it's not working.
Okay, sorry about that.
Good, no, that's okay. We'll try one more time.
How's that?
That's it. You're
oh,
there.
Great. Sorry. Good. Sorry about that. And thanks for having me on. And I'd like to say to the other speakers that it was it's been really interesting so far. And I think you'll see links with what I'm trying to show you today. So I'm going to show you a case from Norway. And I'm employed obviously at the Norwegian Institute for Sustainability Research, and we changed our name last year. So some of you may recognise us more as Østfold Research, just so that you realise that. Here we go. What's happening now? Are you getting the next slide? There. Yeah. The SirkulærPlast project is a regional research project with a budget here in Norwegian kroner. There were 13 partners in the project. So it built on a previous and relatively small project financed by the Oslofjord Fund and Green Dot Norway, as well as the partners Borg Plastnet and Bjorba. They are collaborators despite being also competitors in a fiercely cost-driven market. And here, I do apologise, but I think my presentation is not responding to clicks. It's just going forward. But anyway, we'll move on. The value chain for the whole life cycle of the plastic product is important and in focus here. We need to have actors for the whole value chain, and I think, as you've seen earlier today also, it's quite complex. So we need to make sure that the different perspectives are all taken care of, and that the different actors can make use of project work like this from their perspective. And it also leads to a lot more learning, which I'll come back to later.
Hello, Andre. What happened here?
I guess she just dropped out. I think she's having some problem with her internet or something else like that.
Oh, no. All
Yeah.
right. Well, whilst we try to get Cecilia back, perhaps we should ask Thor if he is ready to do his presentation. Thor, whilst I introduce you, do you reckon maybe you can get yourself ready? We've got Thor Kamfjord, who's Director of Sustainable Development, and he's going to talk to us about closing the gap to enable increased circularity of plastics. Thank you, Thor. Please, take it away.
I will do, and thank you, and I'm ready. Let me try to put your minds into at least 3 ways to close some of the gaps we need to address to really increase the circularity of plastics. And but before I start, just a few words about the company I'm working for, Nomer, which is an innovation and research company based in Norway, working all through the value chain from the polymerization to the final end use of plastics in a variety of industries. And once this COVID situation is over, we hope to invite you to our new polymer exploration center in Norway, which are being built right now. This center is also part of one of the 5 catapult centers supported by the Norwegian government, and we are responsible for the polymer materials. But really looking forward to see you there. We work all over the world and with research, development and advice, and also advanced testing. And without going into details, we have a significant laboratory facilities to support the different research and development projects we are doing for the industry. We strongly believe that collaboration is a real key to resolve the complexity in order to close the loop. And that is why we work with our clients in funded projects, both on a national level and on an international level, really dealing with the, let's say, the most challenging tasks which we see needs to be solved. But the main chunk of our business, 80%, is business to business in the value chain, where we cooperate with the industry with one or more partners to really address the issues which needs to be solved right now. And we are also part of several cooperation platforms which are there to actually address these issues as a common effort. I will not have time to talk about renewables today, but I will talk about making plastics recyclable and also recycled and actually being used in existing value chains, which is a little bit of the challenge which we have today. Because up till now, we have been really designing for functionality, down-gauging, and convenience. But now we also need to, let's say, embrace designing for circularity. And that is a challenge, but we are starting to see that companies are doing it right now. And that is also, so the beauty of that now is that industry has now agreed in Europe how to do it for packaging, meaning they have agreed on let's say a certification scheme to really drive the packaging into more recyclable solution through a free tool called Recipo, where you can use an online tool. You have your design for recycling guidelines, and you are able to get your packaging certified. And I think that methodology behind this is worth to, let's say, transfer into other product areas, because it's quite sensible, the things which are being doing here. For products which are falling out of the design for recycling guidelines, or if there are uncertainties, you will be able to test your product and compare it to what will happen in call it a agreed and standardized recycling stream. And that is what we are doing. So we are also taking part of this Recipo scheme now as Nomer. And it's so great to see that, let's say, it's also possible now to get your recyclability rate certified. So one thing is to have your materials or products designed for recycling. The other thing is to actually consider which markets are you selling your products to, and is it actually being recycled in the, let's say, the relevant markets. And if so, you can also get your recyclability rate certified. What you also see now is that companies are starting to share. So this is an example from Colgate, where they have actually changed their packaging of toothpaste into a solution which are being Recipo certified, are sharing the way and how they have been doing that. And it's clearly that it is A and B's we need, so solutions which are not having a significant impact or not at all on the recycling, the plastic recycling stream. And as I said, we will now be one of the laboratories who can do the complementary testing to support, let's say, the digital and online tool and the design for recycling guidelines. So now it's possible for the industry to really speed up the concept of designing for recycling. So let's see, we start to sort that out. What remains is clearly that we need to do much more work on quality, because what you see in front of you right now is the answers from the industry. Why are we not using more recycled plastics? And the answer is now quality. Price is also an issue, but not the most, let's say, frequently occurring answers of why are we not using more recycled materials. And one of the answers to this is that with the current way of working, we are recycling materials into average qualities or even downgraded. On the right-hand side of the screen, you see a typical product portfolio offered by a resin supplier, meaning they offer dedicated grades with specific property profiles for thinner packaging, houseware, caps and closures. And what happens when we recycle it today? We take all these dedicated property profiles and put them all together, for example, all in one polypropylene stream, all in one polyethylene stream. And what happens then? We make an average grade which doesn't really fit into any of the applications or specifications which industry require to make new caps out of recycled material. that is a big challenge today, where we kind of lose properties in the way we recycle today. And here you can see, here are the property profile of different virgin grades offered to the market. And what happens when you recycle it? You average everything off and are, let's say, excluded of introducing such materials in relevant applications for recycled materials. So a lot of things are happening in Europe now with advanced recycling. And here's an example of a very good recycler who do a lot of sensor-based sorting, are able to offer not 50 shades of gray, but good base colors for the different materials. But still, it's a challenge to keep and maintain the property profile. So we need to actually get out of this system error where we are sorting out of spec and starting to, let's say, retain more of the properties which are inherent in the different application areas. And then a second thing which we see that the recycling industry needs to put more attention on is that actually additivation. Because what happens is that when we recycle a material, and now I'm stuck again, now I move on. Actually, what's happening is that in one recycling step, the material has been processed 3 times by temperature and shear. And what happens then is that you have this degradation, because originally this was stabilized for the intended use, and the additives which was there are being consumed. And once you get to the, let's say, the new processing steps, there might be no processing stabilizers left, and then you start to make again poor quality. So we have measured this and see that for, let's say, for the virgin materials, we have a given level of process stabilizers. After, for example, extrusion blow molding, you have consumed your active process stabilizers, or when you are offering that again as a recycled material, there are no process stabilizers left. And then you start to make, let's say, a product which can break and which will deteriorate during use. And that, of course, is not acceptable. And we also see that these here are 5 commercial post-consumer grades being measured, where actually we see that the current additive levels are way too low to be actually be suitable for a commercial use. So we need to actually have that in mind, that actually also we need to additivate for circularity. And now the recycling industry starts to get this attention, but still a lot of competence regarding formulations are required. It can be solved by, for example, adding new fresh additives every second extrusion. So here there is a development of the melt flow rate, which will increase if you don't add any additives. But if you start to, on every recycling step, add a little bit more fresh new additives, you can retain your properties. It will impact the mechanical properties if you don't. So it's got obvious that you need to do it. But still, even though we add, let's say, conventional additives frequently during the recycling, let's say multiple recycling, still there are changes in properties, meaning the current additivation packages are not suitable or developed for the circular economy. If I just want to sum up, obviously we need more collaboration and sharing of knowledge, because the knowledge are not in some areas present at the time being. We need to secure that, let's say, the end users and brand owners really secure that the materials are designed for recycling and take out the complexity. Of course, also work on the market side to implement the use of recyclates. We believe that the recyclers really now needs to stop acting as the waste management company, but start acts as resin suppliers with the right quality and application mindset. And that means we need to rethink. We need to have more closed loops, and we might even need to have more, let's say, advanced AI technology. For example, recognizing that now there is passing a cap. I put this PP cap in a given stream because then I have a cap material which can be used again. And then also we need to secure that the way we stabilize our polymers are actually stabilized for circular economy and not the intended first times use. So there are some system changes required and some new thinking and some new innovations that needs to be made, but I'm sure we will get there, but it definitely requires a collaborative effort. Thank you
so much. Thank you so much. Some optimism there and some great insights. Look forward to discussing a little bit more the collaboration aspects that are so desperately needed between OEMs, producers, and recyclers. Thor, thank you so much. Cecilia managed to log back in again, and we're going to give her another chance. She's going to talk about realizing circular innovation in Norway. Thor, thank you. Cecilia, please, let's have another go at that. So, Cecilia, are you with us there, or are you muted? Okay.
It seems that Cecilia is having some problem, maybe with her computer or internet connection. It's just frozen again.
This is a shame. I'm sorry to hear that, Cecilia, if you can hear me. But everybody else, Martin in particular, we're going to move on. Martin Seemann, who is an associate professor from Chalmers University, is going to talk to us about the transformation of existing petrochemical clusters into thermochemical recycling plants. This is very exciting. Please take it away, Martin.
Yeah, thank you, David. Yeah, I'm Martin Seemann. I'm from the Department of Space, Earth and Environment. So we feel a great responsibility for our environment beyond the boundaries of the Earth. And I would like to walk you through a little bit our thinking, both in utilizing assets that we have in our industries, dealing with their need to replace the feedstock, and the issues that we have with plastic recycling. I will look a little bit that in a longer perspective, like looking ahead. I mean, what is our long-term goal, which we want to meet here? And we look in 100% circularity of the carbon and plastics. And as well as this is a local issue where you have the production, we would like to mitigate the CO2 emissions. So we have looked on those two aspects. We have done a study there, and I will give you some insights into this and some discussion around this, as much as we managed to do in 10 minutes. Just a very short to clarify where we are. When we look on recycling methods, I would like to distinguish between selective methods, where we have like mechanical recycling, where we take a part of the overall waste, plastics, and recycle that one. So we get a residue. And then we have the general methods that we can look at. And there we have the incineration, where we could do carbon capture and utilization. Where we can see here that is the product, and we have the energy demand to basically lift the product back into new polymers. Then we could do gasification, where we could have a syngas, some carbon dioxide, and this would be the energy demand to lift it back into new polymers. And what I want to talk about today would be, as we call it, the monomer route or chemical recycling, where we aim to gain monomers from our feedstock. You always, and you do those kind of processes, you get a share of syngas, you get a share of CO2. And this would be just symbolizing the corresponding energy demand to lift all this product slate back into new polymers. So if we look a little closer, we talk about, I mentioned here, high and low temperature pyrolysis. So what are we talking about? Low temperature pyrolysis would be in a range of a couple of 100 degrees, where you generate a naphtha fraction. You get some byproducts, you get CO2. And then you usually go through anhydration and go through a traditional steam cracker. So this is something that has been tested and done, and there we are already having quite a piece. what we run through the steam cracker here, the 100%, this corresponds here, the 100% of carbon in the naphtha. So we still have the byproducts that we get from the pyrolysis. And then we have been looking at high temperature pyrolysis, which I would like to call as well direct cracking. So this would be a direct cracking of the plastic waste, where we turn it into monomers as carbon dioxide. And again, I mean, here it's just this is a symbolic representation of the energy demand that would be required to lift it back into new polymers. Good. So what have we been doing? We have a plant here at Chalmers where we can do different gasification, cracking, pyrolysis experiments. So we have been running trials with 1 ton a day, which corresponds to 50,000 plastic bags roughly. Just estimating to test this idea, this technology. There has been a lot of trials already during the 90s looking on different kind of options here. So there is a lot of around. And then based on that, we have been using our experimental results and looking into state-of-the-art technology, how you turn monomers, syngas, and carbon dioxide, which is a result of what we do here of this high temperature pyrolysis, into new polymers. And close to Gothenburg, we have a chemical cluster producing plastic on a relatively large scale. And we have been using actually their environmental reporting to make this assessment, what would be needed, what is the requirements. So looking into this, we have established 3 scenarios. So there's a scenario where we only replace the feedstock, which is naphtha and ethane, for this case, with plastic waste, and CO2 would go to the atmosphere. Alternatively, one could employ CCS. The next scenario would be that we replace the feedstock with plastic waste and waste wood. And again, we have the storage of the carbon dioxide as an option, or it goes to the atmosphere. And then scenario 3, which would comply with what I saw, as I mentioned, as the long-term perspective that we have here, would be the replacement of the feedstock, and as well turning carbon dioxide into plastic and have a smaller share of carbon capture and sequestration. So that's the 3 scenarios, and I will show very briefly a couple of results that we have there. You can find much more and much more detailed as well in this in the publication. Yeah, I just walk you through that, and then we'll see how much time we have and what kind of questions pop up in the discussion afterwards. Good. So if we look at this petrochemical cluster, the first thing that pops up is that we actually talk about a very large amount of plastic waste. So we talk about in the order of magnitude 1.7 million tons of plastic waste that would go to this particular cluster to replace all the naphtha and all the ethane that goes into this cluster. So this would be the first scenario where we still emit CO2. And then we can look at the scenario 2, where we as well implement waste wood as part of providing heat to the process, and where the CO2 emissions could be accounted in a different way as not being fossil there. And then we have the scenario 3, where we basically capture the carbon dioxide and turn it as well into plastic. And this reflects very strongly, as you can imagine, in the electricity demand, because the turning carbon dioxide back into plastic requires a considerable amount of hydrogen, and here we assumed electrolysis to being the source for the hydrogen. So there we have a quite impressive amount of electricity that would need to be provided to this particular site. So going a little further and looking on the efficiencies, I stated that, I mean, the long-term goal that we should have here would be 100% of the carbon that we have in our polymers and in our plastics that we could turn this again into plastic. And I think this is something that we right now fail even in our advanced technologies that we apply. And if I might point you towards the second graph here, one can see that today's scenario, a petrochemical cluster is relatively good in basically cherishing the carbon that comes in. And one can see that plastic, as naturally one can assume, is not the perfect feedstock here that one could have. But basically, looking in the final scenario, there is obviously the possibility. I mean, there we come to an interesting question which we did not address here. Do we as a society value that to a degree that we are committed to paying this price here? Price is the next point. The investment for such a cluster would be relatively large, or not that large actually. So for scenario one, where we basically replace all the feedstock and set up a new type of cracker for the plant, I mean, we get away with under 20 billion crowns. If you divide it by 10, you're roughly in the euro range for all those numbers. And if you look on the scenario 3, where you basically take all the carbon that comes in and turn it into new plastic, I mean, there is an investment of 35 billion crowns. The interesting part, and I think this is something that might have changed as well. I mean, we did the study was published in 2019, and things have happened since then. The markets have developed. I mean, during that period, this was around when China changed, or recently had changed the import of plastic waste to the region. And there basically there was no demand for mixed plastic waste. So we assumed a cost of €0 per megawatt hour. We have as well looked into different pricing, so it does not change the picture completely, but obviously it has an impact there. But it's like this, that actually naphtha is not for free. I just put here the bulk price of butane. So one can see that this is roughly €30 per megawatt hour. It could be, I mean, we assume the price range for mixed plastic up to €10 per megawatt hour. When you look on the different scenarios, you can see that actually there is a gain to make in those scenarios, and it points towards that there is as well an economy to actually take on this investment. But obviously, I mean, it's a large investment, and this is a risk that is behind that. You probably have heard as well the announcement of Borealis that have made an announcement the end of last week, beginning of this week, that they are going into this kind of recycling and choosing the low temperature pyrolysis to start with. So there are things moving in that direction, and I think this is great news for us looking into chemical recycling, that actually the actors are moving in this direction. Just to summarize, I mean, from what we see here, 100% circularity of carbon and plastic is actually possible, and if we desire as a society, we don't need to emit fossil CO2 to the atmosphere. It includes, however, that we really take care of all the parts that come out of a chemical recycling. So not only the monomers, but as well the syngas and the CO2. And I think we can make a case that it's feasible both technically and economically. So thank you for your attention, and I hope for having a good discussion afterwards.
Thank you very much. Thanks, Martin. Wow, that's food for thought. Should mechanical recycling continue if pyrolysis is ultimately better? that's maybe something that we can discuss a little later on. Cecilia, we're going to do try number 3 here. And I understand you're going to get a little bit of help from technical support. So it's looking great. Please.
Lovely.
Please go ahead.
Thank you so much. So I think here and explaining that these partners and collaborators are competitors actually in a fiercely cost-driven market. But we started with a preliminary project where we identified research questions for a main project, and the funding for the main project and the preliminary project was also partly or considerably financed also by the partners. So yeah, if you could click forward. Thank you. And so you see the recycling value chain here for these plastic products, and click, please. And you'll see we had design partners, and the next one, please. And the plastics producers are shown here, and the Board Plus network is also involved. And the next one, please. And the sorting companies, Roaf and Rangsells in Norway. Next, please. And then Clariant additives, as Thor was mentioning earlier, additives are quite important, and quality testing is really important to know that the design and the production requirements are met. If you could go forward, please. And this is the region of Norway where the activities were taking place. If you could go on to the next slide. So we had 3 cases, and these are products that you probably wouldn't see as a consumer, some of them. So the railway parts for railway tracks, which is glass reinforced polyamide or nylon, is part of the railway track construction. And then there was a polypropylene product, which was in the back of a vehicle, and then a high density polyethylene bottles, which were the cases for the project. If you could move on, please. So all the results are publicly available. We tried to make a resource so that this learning could be shared. And this website is hosted by Grønpunkt Norway, so Green Dot Norway, sorry. It's in Norwegian, I'm afraid, for the ones of you who don't read Norwegian. But for those of you that do, I hope it's a useful resource. And there's also various reports, some in English and some in Norwegian, about life cycle assessment and odor properties testing we did in the project. So there's a lot of information there that we gathered over all of the years we had the project on, and learned a lot from. So if you could move on, please. So main findings, because here I wanted to talk mostly about the network aspects and the findings. So the main scientific findings was, and this is mechanical recycling, just to go back to what previous speakers have talked about. Recycling can give environmental benefits. In these cases, these actual cases, we found a climate change reduction of 2 to 7 kilos of CO2 equivalents per kilo of material we replaced. And it's really vital that you must actually replace virgin materials, not just make products for the sake of making something out of recycled plastic. So if you want to get the environmental benefit, and we did life cycle assessments on all these cases. Also, it is environmentally sensible to recycle in Norway, to do the whole recycling process, the value chain for it in Norway. The transport and energy burdens are lower, and it's beneficial for traceability and availability for Norwegian plastics products producers. That was something that everyone struggles with, I think. Products without food contact. There's a lot of focus on packaging and products with food contact, but there's a huge potential for the use of recycled plastic, and it does have an environmental benefit as long as virgin plastic is replaced and the products have adequate quality to do the job that they're supposed to do. Please move on. Knowledge and learning, if you click. Some results. The value chain perspective was very important, and click in again, please. The sources of recycled materials are very important. Product specifications, designers, so which specifications are required by designers, by customers, and what range of material properties are okay. So often there's a specification given, but not a range of what's okay. And if you could click on. And it's really important to get knowledge-based sustainable design, and not do greenwashing, basically, that it's actually based on factual knowledge. And it's important with communication and understanding of the value chain. If you could go on. And then actually developing new products or replacing developing products that exist with recycled plastic. It takes time and resources, and that needs to be factored into your development process. And next one, please. Yeah, and one thing, there's a Norwegian expression, ildsjæle, which means literally fire souls, and that was a really important part of why this project was a success. There were specific individuals in the different companies that really wanted to make this work and really put a lot of time and effort, and also stopped their factories, got production tests done, were very innovation orientated. And I don't know that without those we would have been so successful, but it made it a really good project to work on. Please move on. The participants, I surveyed participants in the project at the end and asked them what did they learn and what did they think was most important. If you could click. They said that this focus on materials quality and the ranges of tolerance is a very crucial thing, but it's actually lacking and actually where the customers are concerned in their specifications as well. Click, please. Development and testing of standardized data sheets. I was really interested to see the work on standardization shown earlier. From someone outside, it might be worth knowing that it's quite hard to find out what the status is and what the progress is, because there's all these committees that have to work. The people who need to use recycled materials would really love to have standardized information. So that would be really useful input there. Please click on. Odor reduction technology tests. We did them in the project and we calculated the difference in environmental burdens by using this, and it worked and it was fine. The increase in burdens weren't too much to take away the benefits. Click on, please. We did life cycle assessment, as I've mentioned, for the cases. And then laboratory and industrial scale testing of the recycled materials. So the materials were tested in a lab scale first to see if they met the quality requirements that seemed to be okay, and then tested on an industrial scale if they did. Click on, please. Yeah, and these aspects again of traceability, quality control, and LCA. It was interesting for everyone to realise that it would be better if the whole cycle could be found in our country, in Norway. Please click on. And there was material knowledge packs that were developed for designers. And please click on. And yeah, design for recycling knowledge. What Thor also mentioned earlier was the importance of antioxidants, including the first life cycle. So if the initial material has been designed with so little level of antioxidants as possible to make it as cheap as possible, it is then really hard to recycle it. Please click on. And the additives, learning about additives, what they are, it was actually very useful for because plenty of the plastics producers themselves, the products producers, they order ordinarily a master batch and they don't specify necessarily additives, they specify what they're going to use it for. But then learning about the different additives that were available and what knowledge they could use them for was really useful and powerful for them. Next slide, please. Yeah, and I just wanted to sum up, and thank you for your patience with these technical difficulties. The project, if I was going to sum up, I would say it was about having flexibility, and click, please, and communication between all the actors, and again, please, one more click, and sharing the knowledge. So this expression at the top of the slide, spille hverandre god, it's a Norwegian expression which is about playing together to make everyone good, and I really think that applied here. So it was a really good success and a good example of network where with positivity, despite competition for some actors, it was really helpful. So please click on. Yeah, thanks for your attention. That's all I'm going to say. Sorry about the technical difficulties, and thanks very much, Andre, for your help now.
Well, thank you very much, Cecilia. Thanks, Andre, of course, for being able to help us out with the technical issues. Wow, I'm really happy that we sorted that out, Cecilia. Also very interesting, and it's nice that Kristin sent a little chat message whilst you were talking, saying that one of their current ongoing standardization project is regarding quality specifications for, it says, recyclates.
Yeah, that's really important. So it's great. And I'd love to hear the news on that when it comes, Kristin. Thank you.
Well, let's bring all the speakers back in. Hello and welcome again, and thank you. There's been a few different questions that have come in. Some have come in from the speakers themselves, and others have come in from some of the participants who are listening in. I've got I'm going to grab just the top one here, and it's specifically a question for Thor, but it's in terms of attempts to attain high quality recycled materials. Where does the responsibility lie in sorting the different types of materials? Is it the municipalities or governments, or where do you want to point the blame, or what areas of that would you like to see worked on?
As I try to stress, this is about, let's say, working together. But as we see it now, I've been seeing it for quite some time, what we really need to point the finger at is the market. Because what are we really recycling into? Who are willing to use and who are willing to purchase? So, I mean, we need to, let's say, work on, let's say, the market development and, let's say, actually creating a market and willingness to start to use these recyclers. Otherwise, I mean, it's kind of help without any use. So that is where we actually see the big challenge today, that we need to have the commitment. And actually, there are several projects going on right now, and also we want, let's say, the public sector taking responsibility to develop the market. Because yes, it's more costly than virgin normally. There's a little bit special price on virgin right now. But we see that there are, let's say, several projects used by the public sector where recycled materials can be used. And if they are not willing to buy it, who should be willing to buy it then?
Well, I've heard obviously something that would benefit us in this discussion, but are the prices on virgin plastic too low? Should they be forcibly made higher? Well, of course, we'll all say yes, but you know, with a discussion around that, how easy is that to do? Are we all waiting for, you know, in Europe, the 2025 Green New Deal or Green Deal? I don't remember exactly what it's called, but is that what we're all waiting for? And until then, please.
Yes, well, I would agree on what Thor was saying. This is a market driver. If the market is driving a need for recycled material, this price discussion will be redundant, I would say. You can see it on recycled polyester. You can see it on recycled PP for injection molding. So if big brand owners goes out and say, we will use recycled material or public procurement, then it will happen.
And will it be standardization that will drive innovation and research?
That was my question. Yes. Yeah, and that was the response on the 2024 time schedule for the standardization horizon, so to say. But actually, Cecilia gave the full list of the response to that question, because to be able to make a standard, you have to have the data. And Cecilia had all the data to create a lot of standards. Because when you are doing the development for circularity, you create a lot of data collection, and that is the best baseline for very solid, robust, acceptable standardization.
So, yeah, thanks, Kristin. I would just like to add, on that website link I showed earlier, there is a link to data sheets that we developed for the project. So that might be interesting for the standardization group. But I also would like to add, sorry, I just can't show my video just in case of technical issues again. But I wanted to just add also that I'm not sure what the exact carrots and sticks should be. Just that the system now just really isn't working, and so we need perhaps a range of sticks and carrots. We need perhaps, because in some way the people who's going to take the cost for all this extra development you need to use recycled materials, and you can set requirements, and companies themselves can say, yes, I'd love to use more recycled material, but if you want to get real big volumes, it's got to pay in the end, hasn't it, to use recycled materials in some way or other, either because you have to fulfill regulation or because it's a cost driver. And the market itself for virgin raw materials is so unpredictable and at the moment so low for some plastics. For others, it's high. Nylon is an example of it's slightly different, perhaps. But it's a very complex picture, and so you need perhaps a complex set of incentives.
Thank you. Thor, you had your hand up before, Martin. Has your question been? Or...
Yeah, just to make an example, I briefly showed a slide from I would say a leading recycler in Europe who do color sorting and a lot of, let's say, treatment of the recycled plastics. The basis for the investment in all these sorting technologies was that IKEA came in and took a 20% ownership of the recycler because they wanted to get access to polypropylene. And you see the same in other parts of the value chain, that resin suppliers who today are selling virgin understand that in the future, which will be circular, they will be selling recycled resins. And they are, let's say, in principle, selling materials. And they are integrating and let's say, acquiring recyclers. So we see this integration. But then again, we need to have a market to justify the investments, but it will happen. But right now, we need some extra push, and I think we actually need to agree on that for, let's say, given applications, the best choice from any logical reasons are recycled materials. There are, let's say, no functional or other quality reasons of why we should not use. And then we should actually say that, okay, for these applications, we will use more or less, call it 100% or 50, 80, whatever level of recycled materials, because there are applications today which can use recycled materials, and we are not due to the price issue. So yeah, but it's several answers to your question, but let's say right now the market is not ready.
Martin, you had your hand up before.
Yeah, I just had some reflection, because what we right now see is that when you look on the petrochemical industry, they feel this demand. They feel the demand from their customers that they should provide recycled, and they feel as well the demand from governance to change their feedstock. So I think there we push from two sides, and actually when you look on the waste incineration and the CO2, the fossil CO2 emission from waste incineration, maybe there's a third parameter that comes in there. And I think by tightening those aspects in terms of what is the cost for incinerating, what is the allowance to actually take in fossil, and how the market responds. And I think there's what you said, like IKEA is a great example, but there is many more that actually go out, because the increase in cost for your product is not that drastic. So if you spread this out onto each product, it's a very small, it's a tiny amount actually. But I think this push and pull, I think will help. One aspect to standardization, I think what we need to be careful here is because we have had some discussion on how the balancing of those things should work out. I mean, if we choose how we choose our standards for the chemical recycling will basically as well determine what kind of technology solutions they will pop up. And I think this is a super interesting topic. So I can maybe talk to you, Kristin, on this separately.
Back to something that I just mentioned. Sorry, Michael. Go ahead, please. No, please, Michael. No, you muted. Sorry, Michael, you missed your shot. You have to unmute yourself.
There we are. Sorry, I just wanted to add, I mean, from my perspective, you know, I'm working in the trenches, so to speak, on the ground. And fortunately for Recipo material, we don't have a shortage of customers. That's not really our issue. We have people banging on our door, you know, requesting large quantities of recycled plastic. But the question that was initially addressed to Thor was based around the fact that Recipo material are also finding it very challenging to separate these different types of polymers, and it really puts a weight on our capacity to really churn the factory and to produce pellets to meet the demand that's already out there. And by no means is the demand enough. I do agree with everyone's sentiments.
Oh no, you froze there a little bit, Michael.
I do agree with everyone's sentiments that the market should drive this, but it's moving at a very slow speed. And, you know, we need to be creative and inventive in terms of how we speed up this process in order to get these large corporations, these big producers on board, so that their number one priority is to use recycled plastics. But not only that, we also need other, we need to really grow the pelletization business to meet that demand. So I think there are a lot of factors involved that can make it quite a complex thing to solve.
Well, is there a so that I'm going to ask that question now then, is there a future for technical or mechanical recycling when chemical recycling is both, but my understanding is getting cheap. There we go. So you all know the question, is there a future for Recipo material, or is pyrolysis and all of these new techniques just going to be the future? Go, Martin.
I think very clearly. I mean, if you can maintain the structure as Thor, as you mentioned, if you can even keep the properties in the right range, I mean, there is a value in that. I think we sometimes reach the boundary where we say, like, what is the product we're actually doing the recycling for, and then we might change and say, okay, then it might be easier. I think we right now we don't really understand as well the overall costs in society that we allocate to the handling and the processing of this. And I think time will show that, but I see that there is for sure a sweet spot where you have the different technologies cooperating.
Kristin, you also threw your hand up, as did Thor. But Kristin, please.
Thank you. What the plastic industry needs to be very careful about here is that we need to not value necessarily the money, but the environmental footprint, because in the future, the environmental footprint will be the money. So when we are choosing the technology for recycling, we need to take the environmental footprint into consideration, and the legislators within the standardization, we are working very closely to the Commission. And they are very clear that the decision needs to be taken out from an agreed environmental footprint calculation. So this will be the selection criteria in the future. We are not the choosers, as I see it, at least, because the legislators will do it for us. And when it comes to DG Enviro, they are not necessarily always asking the industry for input. So this is a very important question to take into consideration. If we want to create the environmental, the environment for the industry ourselves, we need to take the lead and do the right thing. And the industry, historically, plastic industry, have not necessarily taken the right decisions for the time. So when we, in 10 years, are revised based on the decisions we take today, we need to think long term.
Thor, we've got 1 more minute. You've got 30 seconds. Do you want to add anything?
Yeah, just saying that most part of the industry, I think, agree that there's let's say a joint future for the mechanical and the chemical recycling, and they will complement each other. As I didn't mention, I mean, during mechanical recycling, we kind of accumulate non-intentionally added substances as well. and we cannot mechanically recycle into, let's say, a never-ending future. So there will be, both will exist. Chemical recycling still have a lot of challenges to solve, but it will be solved. So I think it will be a good future for both of them, but both ways of recycling have the challenges which needs to be resolved to really both make a low LCA footprint and also good economics and performance out of what is coming out.
Thank you very, very much. I've gotten a warning. We are shut down now. Recording will stop. Thank you so much. It's been highly appreciated and lots of great information. Enjoy the rest of the materials conference. Take care, everyone. Bye.